Imagine a world where the sky suddenly loses one of its most beautiful and mysterious displays. A world where the long dancing curtains of green and violet no longer shimmer above the Arctic night. A world where the Aurora Borealis, the northern lights, simply disappears. Most people would assume it's nothing more than a beautiful phenomenon fading away, a natural light show gone quiet. But scientists would immediately understand something terrifying if the aurora stops appearing. It means Earth's magnetic field, the invisible shield that protects our planet from cosmic radiation and solar storms, is failing. And if that shield collapses, life on Earth enters a new and dangerous era. To understand what would happen to Earth without the Aurora Borealis, we need to understand what the aurora actually is. Most people see beauty. Science sees a warning. The aurora is not just light, it is the physical evidence of Earth's magnetic field intercepting deadly particles from the sun. When solar wind, a constant stream of charged particles, hits our magnetosphere, those particles are redirected toward the poles. They collide with oxygen and nitrogen atoms in the upper atmosphere, releasing bursts of energy in the form of glowing light. It's like a cosmic collision producing a spectacular light show. If the auroras stop appearing, it means this entire process has been disrupted. And there is only one explanation. The magnetic field is weakening or collapsing. Earth's invisible shield is failing. Deep beneath our feet, molten iron and nickel swirl inside Earth's outer core. These swirling motions create powerful electric currents. And because a moving electric charge generates a magnetic field, these currents act like a planetary-sized dynamo. This dynamo creates the magnetosphere, a gigantic protective bubble that deflects the solar wind. Without it, the solar wind would crash directly into Earth's atmosphere and begin tearing it apart, stripping molecules away into space. This exact fate happened on Mars. Mars once had oceans, rivers, and a thick atmosphere. But when its core cooled and its magnetic field died, the solar wind slowly stripped away its atmosphere. Today Mars is cold, dry, and exposed. Now imagine Earth on the same path. The first hours without auroras would go unnoticed by most people, but scientists would quickly detect anomalies. Magnetometers around the world would register strange fluctuations, sudden drops in intensity, and chaotic, unpredictable variations. Satellites measuring the magnetosphere would detect that it is shrinking inward, unable to withstand the solar pressure. Airlines flying over the poles would immediately reroute their flights. Radiation levels there would spike rapidly because the magnetosphere normally blocks most of the harmful radiation. Without it, passengers and crew could be exposed to dangerous levels of cosmic rays. Polar flights would become impossible overnight. GPS systems would begin to fail. The accuracy of navigation satellites depends heavily on the stability of the magnetosphere and the ionosphere. Without the magnetic field functioning properly, GPS signals would bend unpredictably. Ships, airplanes, and even smartphones would start showing location errors of dozens or even hundreds of meters. Military operations would be severely disrupted. By the end of the first week, satellites would start malfunctioning. Orbiting satellites are built to withstand some radiation, but without the magnetic field to soften the blow from the solar wind, they would be directly exposed. High-energy particles would penetrate their electronics, causing random bit flips, short circuits, and total system failures. Weather satellites, essential for predicting storms and global climate patterns, would be among the first to be compromised. Animals would sense the change long before most humans understood what was happening. Thousands of species depend on Earth's magnetic field for navigation. Whales use geomagnetic cues to migrate across oceans. Birds rely on the magnetic field to travel thousands of kilometers. Turtles, insects, even certain bacteria depend on it. Without a stable magnetic field, these species would become disoriented. Bird migrations would collapse. Whale strandings would increase dramatically. Entire ecosystems could destabilize. Meanwhile, on the ground, people would experience a subtle but unsettling shift. Compasses would begin pointing in strange directions or spinning slowly. Magnetic north would drift rapidly, sometimes kilometers per day. Schools would have to teach children that you can no longer trust a compass. The world's sense of geographical stability would begin to fade. As months pass, a larger crisis unfolds quietly in the atmosphere. High-energy solar particles, no longer deflected, would begin damaging the ozone layer. Ultraviolet radiation would increase significantly. Outdoor exposure during peak sunlight hours would become dangerous. Rates of skin cancer would climb. Crops that depend on stable UV levels would begin to wither. Plants would get sunburned. Agricultural yields would drop, and food prices would surge. The aviation industry would enter a crisis. High-altitude flights would expose passengers to dangerous radiation levels. Airlines would have to fly at much lower altitudes, burning more fuel and increasing global transportation costs. International travel would become slower, more expensive, and far more dangerous. Meteorology would collapse into uncertainty. Without weather satellites and a stable ionosphere, climate models would lose their accuracy. Storm tracking would become unreliable. Hurricanes could strike with little warning. Entire coastlines would become vulnerable. But the most catastrophic changes would occur at the edge of space. The upper atmosphere, constantly bombarded by the solar wind, would begin to heat and expand. This expansion would increase drag on satellites, causing many to fall out of orbit. Space debris would become a growing hazard. The chain reaction could resemble a Kessler syndrome, a collision cascade that fills low Earth orbit with fragments, crippling future satellite launches. Now, imagine the long-term effects. Without a functioning magnetic field, Earth's atmosphere begins to erode. Slowly, year after year, the solar wind strips away molecules. At first, the loss is too small to notice. But over centuries, atmospheric pressure would decrease, the composition of the air would change. The climate would become unstable. Temperature differences between day and night would grow more extreme. Ocean water would evaporate faster. Weather systems would become chaotic and unpredictable. Over thousands of years, Earth could slowly transform into a thinner, colder world, a planet starting to resemble early Mars. Human civilization would be forced underground or inside sealed habitats in high-latitude regions. Radiation would become a daily threat. Electronics would require heavy shielding. Agriculture would move indoors permanently. Human life would continue, but the planet would be permanently altered. And through all this time, people would remember the first warning sign, the disappearance of the Aurora Borealis. But here's the important part. This scenario, while possible, is not guaranteed. Earth's magnetic field weakens and strengthens naturally. Every few 100,000 years, it even reverses. Magnetic north becomes south, and vice versa. During these reversals, the auroras can appear near the equator. People in tropical countries could look up and see bright green lights overhead, but the field never disappears entirely during these reversals. It weakens, but it recovers. The aurora shifts, but it survives. What we truly fear is not a reversal. It is the permanent shutdown of the geodynamo inside Earth's core. If the core cools too much and stops generating electric currents, the magnetic field would collapse permanently. And if that happens, the Aurora Borealis would vanish forever. So the next time you see the shimmering lights in the night sky, remember this: they are not just beauty. They are the visible heartbeat of Earth's magnetic shield. They are a sign that our planet is alive, protected, and still fighting against the sun's relentless fury. If those lights ever fade forever, it means the heartbeat has stopped, and the consequences would echo through every corner of life on Earth. If you want to keep exploring the hidden physics of our world and the mysteries that shape our universe, make sure to subscribe. Your curiosity powers everything we do here, and together, we'll continue unraveling the secrets of the cosmos. Thanks for watching.